Chemistry Syllabus, Physical Chemistry, General Topics, Concept of Atoms and Molecules, Dalton's Atomic Theory, Mole Concept, Chemical Formula, Balanced Chemical Equations, Calculations based on mole concept involving common oxidation, reduction, neutralisation and displacement reactions. Concentration in terms of mole fraction, molarity, molality and normality. Gases and liquid states, absolute scale of temperature, ideal gas equation, deviation from ideality, Van der Waals equation, kinetic theory of gases, average, root mean square and most probable velocities and their relation with temperature, law of partial pressures, vapor pressure, definition of gases, atomic structure and chemical bonding, Bohr model, spectrum of hydrogen atom, quantum numbers, wave particle, duality, de Broglie hypothesis, uncertainty principle, qualitative quantum, mechanical picture of hydrogen atom, shapes of s, p and t orbitals, electronic configurations of elements up to atomic number 36, alpha principles, Pauli's exclusion principles and Honda's rule, orbital overlap and covalent bond, hybridization involving s, p and t orbitals only, orbital energy diagrams for homonuclear diatomic species, hydrogen bond, molarity in molecules, dipole moment, qualitative aspects only, DSEPR model and shapes of molecules, linear, angular, triangle, square planar, pyramidal, square pyramidal, trigonal, bipyramidal, tetrahedral and octahedral. Energetics, first law of thermodynamics, internal energy, work and heat, pressure volume, work, enthalpy, Hess's law, heat of reaction, fusion and vaporization. Second law of thermodynamics, entropy, free energy, crystallization of spontaneity. Chemical equilibrium, law of mass, action, equilibrium constant, Lee catalyzation principle, effect of concentration, temperature and pressure. Significance of Tg and Tgo in chemical equilibrium, solubility product, common ion effect, pH and Puffer solutions, acids and bases, Bronsted and Lewis concepts, hydrolysis of salts. Electrochemistry, electrochemical cells and cell reactions, standard electrode potential, Nernst equation and its relation to Tg, electrochemical series, EMF of galvanic cells, Faraday's laws of electrolysis, electrolytic conductance, specific, equivalent and molar conductivity, Kirchhoff's law, concentration cells. Chemical kinetics, rates of chemical reactions, order of reactions, rate constant, first order reactions, temperature dependence of rate constant, Arrhenius equation. Solid state, classification of solids, crystalline state, 7 crystal systems, cell parameters A, B, C, closed packet structure of solids cubic, packing in FCC, PCC and HCP lactase. Nearest neighbors, ionic radii, simple ionic compounds. Point defects, solutions, Ruther's law, molecular weight, determination from lowering of vapor pressure, elevation of boiling and point the depression of freezing point. Surface chemistry, elementary concepts of observation, excluding observation, isotherms, colloids, types, methods of preparation and general properties, elementary ideas of emulsions, surface and Michaels, only definitions and examples. Nuclear chemistry, radioactive, isotope and isobars, properties of rays, kinetics of radioactive decay, decay surface excluded, carbon dating, stability of nuclei with respect to proton-neutron radio, brief discussion on fission and fusion reactions. Inorganic chemistry, isolation, preparation and properties of the following nonmetals, boron, silicon, nitrogen, phosphorus, oxygen, sulfur and halogenous. Properties of allotropes of carbon, only diamond and graphite, phosphorus and sulfur. Preparation and properties of the following compounds, acids, peroxides, hydroxides, carbonates, bicarbonates, chlorides and sulfates of sodium, potassium, magnesium and calcium, boron, diboron, boric acid and borax, aluminium, alumina, aluminium chloride and alums, carbon, oxides and oxyacid, carbonic acid, silicon, silicons, silicates and silicon carbide, nitrogen, oxides, oxyacids and ammonia, phosphorus, Acids, oxyacids, phosphorus acid, phosphoric acid and phosphorine. Oxygen, ozone and hydrogen peroxide. Sulfur, hydrogen sulfide. Acids, sulfurous acid, sulfuric acid and sodium. Thiosulfate, halogens, hydroholic acids, acids and oxyacids of chlorine, bleaching powder, xenon fluorides. Transition elements 3D series. Definition, general characteristics, oxidation states and their stabilities. Color, excluding the details of electronic transitions. And calculation of spin-only magnetic moment. Coordination compounds. Nomenclature of mononuclear coordination compounds. Cisterns and ionization isomerism. Hybridization and geometrics of mononuclear coordination compounds. Linear, tetrahedral, square planar and octahedral. Preparation and properties of the following compounds. Acids and chlorides of tin and lead. Acids, chlorides and sulfates of Fu2+, Cu2+, and Zn2+. Potassium permanganate, potassium dichloride, silver oxide, silver nitrate, silver thiosulfate. Ores and minerals. Commonly occurring ores and minerals were iron, copper, tin, lead, magnesium, aluminium, zinc and silver. Extractive metallurgy. Chemical principles and reactions only, industrial details excluded. Carbon reduction method, iron and tin. Self-reduction method, copper and lead. Electrolytic reduction method, magnesium and aluminium. Cyanide process, silver and gold. Principles of qualitative analysis. Groups 1 to 5. Only Ag+, Hg2+, Cu2+, Bb2+, Bi3+, Fe3+, Cr3+, Ai3+, Ca2+, Ba2+, Zn2+, Mn2+, and Mg2+. Nitrate, halides, excluding fluoride, sulfate and sulfide. Organic chemistry. Concepts: hybridization of carbon, sigma and bi bonds, shapes of simple organic molecules, structural and geometrical isomerism, optical isomerism of compounds containing up to two asymmetric centers R, S and E, Z. Nomenclature excluded. IUPAC. Nomenclature of simple organic components. Only hydrocarbons, monofunctional and bifunctional compounds. Conformations of ethane and butane. Newman projections. Resonance and hyperconjunction. Catronal tautomerism. Determination of empirical and molecular formula of simple components. Only computational method. Hydrogen bonds, definition and their effects on physical properties of alcohols and carboxylic acids. Inductive and resonance effects and acidity and basicity of organic acids and bases. Molarity and inductive effects in alkyl halides. Reactive intermediates produced during homolytic and heterolytic bond cleavage. Formation, structure and stability of carbocations, carbonations and free radicals. Preparation, properties and reaction of alkanes. Homologous series, physical properties of alkanes, melting points, boiling points and density. Composition and halogenation of alkanes. Preparation of alkanes by Wurtz reaction and dicarboxylation reactions. Preparation, properties and reaction of alkenes and alkynes. Physical properties of alkenes and alkynes, boiling points, density and dipole moments. Acidity of alkynes. Acid catalyzed hydration of alkenes and alkynes, excluding the stereochemistry of addition and elimination. Reactions of alkenes with KMnO4 and ozone. Reduction of alkenes and alkynes. Preparation of alkenes and alkynes by elimination reactions. Electrophilic addition reactions of alkenes with X2, HX, HOX and H2O. X halogen. Addition reactions of alkenes, metal oxidase. Reactions of benzene, structure and atomically. Electrophilic substitution reactions. Halogenation, nitration, sulfonation, Friedel-Crafts acylation and acylation. Effect of O, M and B. Directing groups in monosubstitute benzenes. Phenols, acidity, electrophilic substitution reactions. Halogenation, nitration and sulfonation. Riemann-Thiaman reaction, Golby reaction. Characteristics reactions of the following, including those maintained above. alkyl halides, rearrangement reactions of alkyl carbocation, Grignard reactions, nucleophilic substitution reactions, alcohols, esterification, dihydration and oxidation, reaction with sodium, phosphorus halides, incident C12 concentrated HCl, conversion of alcohols into aldehydes and ketones, ethers, preparation by Williams synthesis, aldehydes and ketones, oxidation, reduction, axene and hydrogen formation, aldyl condensation, Bedkin reaction, Genizoro reaction, holoform reaction and nucleophilic addition reaction, Grignard addition, carboxylic acid, formation of esters, acid chlorides and amides, ester hydrolysis, amines, basically of substituted analyzed and aliphatic amines, preparation from nitro components, reaction with nitrous acid, AZO coupling, reaction of diazonium, salts of aromatic amines, Saint-Humeur and related reactions of diazonium salts. Gorbyl-amine reaction, haloarones, nucleophilic aromatic substitution in haloarones and substituted haloarones, excluding benzene mechanism and sign substitution. Carbohydrates, classification, mono and disaccharization, glucose and sucrose, oxidation, reduction, glucose formation and hydrolysis of scores. Amino acids and peptides, general structure, only primary structure for peptidates and physical properties. Properties and uses of some important polymers, natural rubber, cellulose, nylon, Teflon and PVC. Practical organic chemistry, reduction of elements NS halogens, reduction and identification of the following functional groups: hydroxyl, alcoholic and phenolic, carbonyl, aldehyde and ketone, carboxyl, amino and nitro. Chemical methods of separation of monofunctional organic compounds from binary mixtures.